All right, and without further ado, I would like to introduce Dr. Bruno Giordani. He is a professor of psychology and psychiatry, neurology, and psychology at the University of Michigan. And he's also our associate director at the Michigan Alzheimer's Disease Center. So let's give a big hand for Dr. Bruno Giordani.
Yeah, microphone. There's no microphone. There's no microphone. Can you all hear my voice okay? Okay, no microphone. Which I don't know where the microphone is, so we would be. We have subtitles here. I don't know how to turn that off. So.
Definitely has that switch over there. These for the bus scroll.
Oh, lights. Oh, I thought you were. Nobody say anything nasty about me because it appears up here. So okay, I'm gonna leave this chair up here because I have a brace on here, and every once in a while I may sit down. But Stephanie and everybody asked me to talk about to talk about the Alzheimer's meeting we just had in Amsterdam, and sort of give you a kind of a picture of what the latest research is in this area. This isn't moving, Stephanie, so I may. It was working for a while. I can use these. No, but I mean, I can use this. Oop, oop, does. Okay. So anyway, before I do anything, the university requires a couple of things. One is I'm not getting any money out of this, and I don't have any special interests, and it wouldn't make any difference because any money I goes to my kids' houses in Ann Arbor anyway. Also, before I begin, I always like to thank you all, because you all do a lot for research in Alzheimer's. So for example, you volunteer in our studies, which is good. You support our research in other ways by finding other volunteers. And most importantly, you pay your taxes. So if you pay your taxes, some of that money goes to Alzheimer's research. So that's really good. So these are kind of the things I wanted to touch base on today. We're going to review Alzheimer's briefly, the sort of background, just to make sure we're all on the same page when we look at the kind of new research and things like that. We're going to talk about new drug information, blood biomarkers a little bit, new diagnostic criteria, because there's new ways of now diagnosing and classifying, or proposed new ways to classify Alzheimer's disease, talk about some other research, spend a little time on our Alzheimer's Research Center, and I'll spend a little extra time on some of the studies that we're doing there. And as everybody knows, Bruno tends to talk and talk and talk. So in the back of the room are two people who will wave madly if we're running out of time. So we should be okay. So this year, the meeting was in Amsterdam. This was the fourth try, I think, for Amsterdam. But because of COVID and everything else, it was postponed. And this meeting is the largest single disorder meeting in the world. It's Alzheimer's disease. It's not neurology or psychiatry. The whole idea behind this for the Alzheimer's Association was to bring people in from multiple areas, put them all in the same space, and get them talking. So here there were over 10,000 attendees and over 3,000 scientific presentations. And if you so I think it'll be 2 years in the US, 1 year overseas now for a while. But if you look at this too, if you were in Amsterdam, as Brian was, Brian wasn't in Amsterdam. Yeah, okay, sorry. But you would have noticed this, which is this incredible bicycling that everybody does there that seems to be aimed at knocking you down. So, you know, everybody, there's a street, you cross the street, you watch for cars, but then you forget that the bicycles have their own lanes. And so a couple of times I almost got it, but this is a real picture. What they should do is have 3 or 4 people in here so this person can try and hit them. It seems to be a process across Amsterdam. But, so we'll talk a little bit now about the background, and this is Alzheimer's disease and related dementias. Because it's not just Alzheimer's disease, there are other types of dementia that are ongoing and involved. So dementia is really a collection of symptoms related to cognitive decline. But this piece up here, it's an umbrella term used to describe symptoms that are associated with cognitive impairment, but that have a significant effect on everyday life. So people say, is it dementia? Is it Alzheimer's disease? Dementia is that sort of all-encompassing term. But within dementia, there are different types. Alzheimer's is by far the largest. I don't know whether to point here or there, but Alzheimer's disease is by far the largest type. And mixed dementia, which often involves Alzheimer's disease, is many. But there's vascular disease, Lewy body disease, frontotemporal. These are all types of dementias. But a lot of what I'll talk to you about today is Alzheimer's disease, because that's the one we're really worried about because of how many people are involved. But the other ones are just as important, and there's a lot of exciting research going on with them. I wanted to start just sort of a little bit about where we are in the Michigan statistics. And one of the biggest pushes this year in the Alzheimer's Association is to understand workforce problems. We have 164 geriatricians in this state, and if you were going to meet the demand by 2050 for Alzheimer's disease alone, you'd need an increase of 183%. Number of healthcare aides in 2020, you'd need at least a 25% increase to manage what we're talking about. So we're working ourselves into a really significant situation. We have in 2020, 190,000 people. By 2025, Michigan will have 220,000 individuals with Alzheimer's disease. It's an increasing number. The biggest issue as well, and these statistics are a little bit old because of when the research was done, but still in 2022, there were 380,000 caregivers. 66% of them had chronic illness. I mean, many of you may realize this, but one of the issues and real concerns with caregiver research is the whole fact, and we have some caregiver researchers in the front, but is the whole point that 66% have chronic conditions, 31% practically have depression and poor physical health. Caregiving takes a toll. Or people have other problems and they're still trying to caregive when all of that is going on. Number of deaths increases rapidly. So why the big increase? What's going on? Why so many more people? The biggest point is that age is the biggest predictor of Alzheimer's. Among people 85 and up, the percentage of individuals for people who are 85 years old and up is around 40 to 50% of those individuals have Alzheimer's disease. And if you look at what our population is doing, thanks to these guys, it's my fault. I'm a baby boomer. But if you look at this increase, you can see that by 2050, the aging population will be significant. And with that rise in the aging population, it's not that the disease is Alzheimer's disease is being given to more and more people. It's just that we'll have more and more older people in our society. And this is what happens with the number of individuals with Alzheimer's disease. You can see this point here, how high it's 13.8. The number just increases dramatically with age. The other point about this disease, if you think about it, is if you look at the number, what's happening with this disease and why it's significant, is this is the latest data on percentage change in selected causes of death. And what you see is Alzheimer's disease increases dramatically, while all these other types like HIV, stroke, heart disease, prostate cancer, where there's been so much more research, are declining. or staying relatively stable. So that this disorder really presents a very significant problem. Now, I'll give you a little bit of the background. So August Dieter here was 51 years old when Dr. Alzheimer's. So back in the 1900s, if you were a psychiatrist, you were also a neurologist and a neuropathologist and everything else involved. But he was very interested in mental health issues. And when he was at a large mental health hospital in Germany, in Austria, he met her. And she just didn't seem like other psychiatric patients. And he wrote about her symptoms, her forgetting what she was writing when she started, her forgetting names, her forgetting all sorts of different problems, which he saw as primarily related to memory and not fitting a psychiatric disorder. And when she died, he looked at her brain and he published those findings. And what he drew here, and this is his his brain slide is still there. When he drew pictures here, these were pictures of plaques and tangles we'll talk about in a minute that are the key characteristic of Alzheimer's disease. And then his boss at the time, Kreplin, wrote a book and called this disorder Alzheimer's disease. I just mentioned this because you see the politics in the world. At the same time, there was another person, Oscar Fischer, who actually published a little bit before Alzheimer's disease, published 16 more brain samples to Alzheimer's 1 sample, but they didn't have a book, and so it didn't get named after him. And he unfortunately passed away during the Nazi invasion in Austria. So, what are the hallmarks of Alzheimer's disease? How does it work? This is what we understand now, and this is what's really changed over maybe the past 10, 15 years in terms of what's really going on. So these are healthy brain cells. And you'll see there's a cell and there are these little axons coming out that send signals from one cell to the other cell. And that's, for example, when my brain tells my hand flop up and down, it's lighting up all sorts of little cells in the brain circuitry. What happens in Alzheimer's disease, the first thing is plaque occurs. And this plaque is like it's sort of like if you tried to drive between, like we tried to drive from Nova Scotia to Ann Arbor last week. And I can tell you there are more red barrels and more blockages and more this and that on the road. That's sort of what this looks like. What if you're trying to communicate between cells and there's all this stuff called plaque in the way? That's what happens. It breaks down. And you get these misshapen cells as well, because these long axons start to fall apart. And what we understand now is basically the cement that holds these together falls out, the axons fall apart, and this stuff called tau that cements the axons together begins to go back up into the cells, and the cells begin to die and misshapen. So you get plaque and you get tangles, neurofibrillary tangles. This is a classic picture of Alzheimer's disease. We know this now. Back when I first started this work, when I was in grade school, it's a long time ago, but we didn't understand this at all. This is relatively recent in our understanding of this disorder. We know that there's, roughly speaking, in a clear case of just Alzheimer's disease, if you didn't think about anything else that we get as we get older, this is what happens. You get this increased brain amyloid, and this is a basic, so everybody needs, right? You need proteins. You need protein. Your cells need proteins, your brain cells need proteins to get things done. And basically what happens in the brain is you have that nice brain cell with these things sticking out, which are precursor proteins. It's like I have a bunch of vegetables and I need to cut them up. I need a chef to come in and cut them up and give me food. But what happens sometimes, the wrong chef shows up. The wrong enzymes show up. And when they cut that precursor protein, it's not in the size and shape that brain cells can absorb. So you get these clumps of plaque or oligomers. And when that starts to happen, you get brain inflammation. And then as that happens, you start to get these tangles forming because the cells, basically, the axons, the way the cells communicate starts to fall apart. And then eventually cells die. Neurochemicals aren't produced. The neurochemicals that let me tell my arm to flap up and down stop being produced. And then we notice symptoms. The difficulty is this whole process is about 30 years. And now we understand that. And until this year, this is all we were really affecting in our medications. All of this stuff occurred and there was nothing we could do about it, even though we kind of knew it was happening. And now we can actually do things over the past sort of 5 years, a little bit more than that. We can actually begin to look at these plaques and tangles in the brain, at the amyloid and tau in the brain. We can look, for example, at PIP scans that show us where the amyloid first begins to appear in the brain, and at the same time look at tau, where the tau begins to appear. And we notice that there's a slightly different distribution, but those two things together are causing Alzheimer's disease. And if you notice, they're really in these central areas of the brain, the hippocampus. Why is the hippocampus important? The hippocampus tells us how to remember things, how to do new learning. The hippocampus also, as a matter of fact, tells us how to move around in space, tells us how to remember how to get from Woodward to wherever we're going. So these things begin to get up. These skills are some of the ones that's why sort of why do we have memory problems first is because it starts here. But you'll notice in the front part of the brain as well, you may see problems as well. What does the front part of the brain say? The front part of the brain is what controls our actions. It does our problem solving. It tells me to shut up when I want to say something to whoever my boss may. I was going to say the dean, but I don't want to mention the dean's name, right? But of course now it's everybody can see it right there. But basically, the front part of the brain is the part of the brain that manages our behavior. So that's why we begin to see behavioral disturbance eventually in Alzheimer's disease. But that's also why predominantly it starts with memory problems. But we do know that what makes it confusing is some people start more in the front. So we just by the area that Alzheimer's disease affects first, that area of the brain, when those cells begin to die, that's why we see different symptom patterns. But mostly it's in the memory areas of the brain. I want to show you this because this is actually now, there's a fellow I mentioned, Clifford Jack, who's quite famous in Alzheimer's disease research, and he has a model for what happens. And this is his older model. He's now got a really complicated one with every year he comes out with a new model that gets more and more complicated. But what they're basically telling us is, if this is our time before we have problems, this is what is sort of called mild cognitive impairment. This kind of time before we get dementia, when we're doing okay, and we'll talk a little bit about this in a minute. And then this would be dementia or Alzheimer's disease. What happens is, remember that cascade I mentioned? All that amyloid appears in the brain pretty much before we get any symptoms. Right? And then you begin to get tau appearing, measurements of tau appearing, and then later behavior starts to change. But we know that these basic things, the amyloid appears in the brain 20 or 25 years before anything happens. So until we understood that, we didn't know what to do and how to, develop medications. And then medications we did for a long time didn't seem to be working for a number of years. Why? Was because the medications were trying to get rid of amyloid, but in patients that already had the disease, so the damage done by amyloid probably had already occurred. That's why over the past couple of years, the big interest is what happens if we look at individuals who are beginning to develop problems? What if we treat them first? This is why this is a big problem. This is the number of people with Alzheimer's disease that are increasing to 2050. This is the cost. So I will tell you that everybody worries about, Medicare, Medicaid, this or that, breaking the bank. Alzheimer's disease itself will break the bank just because of the incredibly high cost of this disease, because so many more people will get this disease as we move to 2050 because we have so many older people in our world. This is why this is a good thing. Alzheimer's disease and related dementia research funding. People ask me sometimes, well, why didn't you people do something earlier? Why don't we have information? This disease has been known. It hasn't existed. It's been existent forever. If anybody has relatives like I had, and the doctor used to say, oh, memory problems, that's no big deal. That happens to everybody. Well, it doesn't happen to everybody. So now we understand that. But until you got into really 2016, there was still less than 1 million in research. So that only in the past maybe 3 or 4 years has there been such a big increase. So, you wonder why. Well, for one thing, people have become more apparent that this is a big problem. Another reason is a simple politics. There's something called the Government Accounting Office. And the GAO looks 5 years in advance. So if you say to the GAO, we need more money for research because Alzheimer's disease is going to be terrible by 2050, it tells you, well, thanks a lot, but I'm only interested in 2000 to 2005. So what happened is the Alzheimer's Association and a number of other groups got together to change the way that works. So cancer and heart disease, for example, their money comes directly from NIH, the issue of their dollars. The request to Senate comes directly from NIH. HIV, cancer, cardiovascular disease, that's why there's so much research in those areas. Now, Alzheimer's, it took a couple years. It took guys bicycling across and women bicycling across the US to kind of bring recognition to Congress about it. But now GAO has skipped in the requests to Congress for Alzheimer's disease, and those requests go directly to the House and Senate from the National Institute of Health, where they ought to go. And that's the sudden change, and why there's so much research money, and why there's so many changes in what we've been doing since about 2020. It's unfortunately a matter of money. So what have we found out since then? This is sort of kind of a picture about what we understand really goes on in Alzheimer's disease. We know the biggest predictor of all is age, but we understand there are other issues. Inflammation that I mentioned in the brain that causes tau to fall out of cells, that causes all these other issues. We know genetics and lifestyle. We know that certain genes are predictive or are risk management, like ApoE. We now understand that certain genes, like presenilin genes, that exist in very few individuals around the world, but there are some areas where it's much more prevalent, that presenilin genes give you about a 50% risk if your parent has it. So we now understand all these pieces. We understand roles for smoking, all of this stuff. And we also now, more importantly, understand the issue of shared chronic illness. How all these things together lead to mild cognitive impairment, or what we'll call this middle zone. And all of that inexorably, in many people, leads to dementia. We know some people develop problems and it never becomes dementia. And the question is why? What do they have that's protecting them? And, there's a lot of research in ApoE. People talk about ApoE4 as very bad. ApoE2 seems to be good for it. Seems to be protective. So all of this information is fascinating. It's coming out so fast, but it's all because of this change and this recognition about how significant this disorder is. So probably the biggest news that happened before AAIC, but was sort of talked about a lot, was that Leqembi or lecanemab had been not only approved by the apparently the ability to spell is also an early Alzheimer's indicator, I think. But I looked so hard to see if I'd misspelled anything. But anyway, Leqembi was approved. I don't know if anybody remembers any of this stuff, but there was another drug before this, aducanumab, which ran into some problems between the FDA and then the CMS, the people who manage our Medicare and Medicaid, said we're not going to pay for it. We don't have enough. There was just a lot of back and forth. But there was another drug, Onasaze and Biogen. They had two drugs at the same time. And one of them was lecanemab. That was the second drug. So this one is approved. It is covered by the CMS. Patients with Medicare will pay 20% copay as they do for other things, but this drug will be covered. So you need to be enrolled in Medicare, be diagnosed with mild cognitive impairment or mild Alzheimer's disease. Because again, the point in those research is, look, if we get rid of that early curve, remember that early curve I showed you for amyloid appearing, if we can break that early curve, maybe we can break these symptoms. Yeah.
Doesn't it only slow it down maybe 6 months?
That would be good. Yeah.
It doesn't do it in
No, we'll talk about that. Yeah. It's these drugs may slow things down, but if you talk to somebody, if you can say, well, look, this will only change my symptom pattern for 15 months or for whatever you want to pick in there. For many people with Alzheimer's, that makes a big difference. Somebody gets to see a graduation, be there. Somebody gets to do some other things. So but these are issues that you have to consider with these medications. But the big thing about this is, this was the first drug. So once you get one, you'll get more, and I'll talk about some other ones. But the whole point about this is kind of breaking the barrier to get a drug out there. So just for some other specifics about this, the cost is $26,500 a year. So that has to be considered. That's why CMS wasn't going to approve a drug until they saw all the research. And even if the FDA, the Drug Administration, approved it, CMS said, well, heck, before we're going to pay for something, we want to see even more information. Now, ISI does say that they've established they're establishing a patient assistance program. They have navigators. They have a lot of things going on, but all of this stuff is only just beginning now. And at University of Michigan, the status of this is, as of July, it's on the formulary. So as of July, this drug is available, sort of. We've said, okay, we're going to get it. But what's happening now, the first thing is we have to clarify the fact that to get this drug, you have to have proof that you have early disease with amyloid in the brain. The only clear way to do that is to do that with a PET scan. Remember those pictures I showed you before, a PET scan? That's what tells you, well, that's like a $10,000 shot right there. So originally CMS said they would pay it, but then there's some waiver. It's not quite clear. So University of Michigan says, well, let's wait and see. You can also do that through a CSF study, spinal fluid study. It's not it's not a hot topic in the United States to get a spinal tap. If we were in Netherlands, they do it all. You have a headache practically, and they do a spinal tap. But here, it's not something we want to do. So that needs to be figured out. But U of M will follow all the appropriate recommendations. MCI or mild cognitive impairment based on an amyloid marker, because this drug is available to people who demonstrate amyloid. Requires neuropsych testing to confirm mild cognitive impairment. So you have to have a behavioral disturbance in memory or some other cognitive area. You have to have amyloid in the brain. Right now, we're just initially keeping a list of patients who are interested, who are coming through the clinic. If you're not a U of M patient, your PCP, your general practitioner, can give you advice on that and call U of M to get included in this. I assume that Henry Ford is going to have this as well. I don't know Henry Ford's decision on this. But part of the reason why it's so complicated is that we also require an MRI scan ahead of time to tell us what the brain looks like, and before the 5th, 7th, and 14th infusion. This is an infusion drug. This gets infused in the body. It's not a pill. It's not a shot. Neither of those drugs have worked. So it's an infusion study. And why all these MRI scans? Why does your brain have to be looked at? The reason is that there are other side effects, like occasionally like headache, or you may get what's called an infusion reaction, where they put the needle in or things like that. But the biggest sort of side effect in this is called ARIA, amyloid-related imaging abnormalities. This is the biggest side effect and the most significant side effect of basically all of those drugs that are out there to bust amyloid. You do get brain changes. You get sometimes edema that can occur. You sometimes even get hemorrhagic blood vessel changes. Now, the point is, if you look at the actual, placebo, 15 out of 897 people got it, 113 out of 897 who were on Leqembi. So it is an issue, but symptomatic was only 3% and serious was only 0.7%, but you have to monitor this. And the recommendation is, if we see a side effect or something going on, we have to pause. And in general, after that pause, people then recontinue. But there seems to be this initial response. Some people have said, well, if all the amyloid is getting dropped out, something else has to fill up that space, but nobody knows that. Yes.
I'm looking at the second last bullet point that says the incidence of ARIA was higher for ApoE4 monozygotes.
Yep. Oh, sorry, I didn't mention that. Thank you.
That seems so unjust, considering those are people that probably are risking.
Yes. And thank you. I almost went around board. That is the really incidents are ApoE4 carriers. These are the individuals who have the ApoE4 gene that seems to promote or be a high risk indicator for Alzheimer's. Frankly, ApoE4 is a high risk indicator, right, for other things as well. Children who have a tonsillectomy have higher side effects if they're ApoE4 carriers. But we know it means something specific for Alzheimer's disease. And we know that you have an even higher side effect rate if you're an ApoE4 carrier. So people will want to do blood tests to take a look at that, MRI scans and everything. So it's a lot of work to take this medication. So back to your question about that is, people have to make a decision about it. So we'll talk a little bit more about this in a minute when we talk about some new research findings. So these were some of the things that sort of were hot topics at AAIC. This one that last year I talked about a lot, blood tests, still remained a hot topic. But now it's not like, hey, we found this great new blood test. Now it's like, how do we prove these blood tests work, right? Because you don't want that $10,000 PET scan when you come in. You'd love to be able to take a blood test, just like when you go to your doctor and he goes, I'm going to check your cholesterol. What if they could tell you about your risk of Alzheimer's? So blood tests now are being far perfected. Now, I was talking to a friend of mine who's in the back of the room. It's a little bit like the Wild West because everybody claims they've got the they got the best blood test, and it's going back and forth, and which company does which, and because there's so much money to be made in this. But it's still a lot of research. And one of the neatest studies was this finger prick study. They did a study in Alzheimer's clinics that showed if you were in community clinics and did a single, we do this in HIV all the time in Africa, a single prick on a single card, send it in and be checked. That was very effective and much more effective than the physician in determining Alzheimer's disease. So this was sort of one of the first community checks. There was another big study that was announced in Sweden where they also used this in primary care. Again, in a very formal test, primary care, did it help a primary care physician decide on whether the person had Alzheimer's disease or not? And it was 80% accurate. Now, 80% accurate is a little iffy as well, but what this means is we can push some of these things out to the community now to help us even better, because what we keep looking for are community ways to provide risks. The problem is that I'm doing several studies. I do a lot of research in Africa. We're doing 3 studies now where we're looking at blood-based biomarkers, right? Because I don't have a PET scan in Africa, so this is a real key for what's coming. It's not perfected yet, but it begins to be a real key on what's coming. I put this slide up there because it's a slide I used back in, I think, 2015, and I thought, oh, here's the staging of dementia: mild, moderate, and severe. Every year, Clifford Jack, remember the guy I mentioned, Clifford Jack? Very famous, incredibly smart. He gets up every year and gives us a new criteria. Of course, it's always a group of people and a group of scientists getting together and deciding, but it's always, they push Clifford up there and go, you do it, so you get yelled at, not us. But he went up and he explained, proposed a new criteria, a brand new criteria for the range of Alzheimer's disease. One change was there's now a stage 0 for people who have a predictive gene, a significantly predictive gene. And so they don't even have symptoms, but they could be classified as potentially having them. And another thing they did for the first time is said, we're going to include blood-based biomarkers in this. We're not going to just say you have to have a PET scan or CSF. We're going to begin from a research standpoint, at least, to suggest in our research studies that these blood-based biomarkers might just be effective. We're going to be really careful about which ones we use, but we're going to begin to do that. And there are 3, so their abnormal core biomarkers are amyloid PET and tau, those things I showed you pictures of before, and the 2 that are used most often, the blood-based biomarkers, AB4240 and p-tau, that tell you a fair amount about amyloid and tau in the brain. They're blood-based biomarkers. This is the first time somebody's come out and said, some group of scientists come out and said, okay, for at least research, and maybe in years to come moving into the clinic, we're going to begin to use blood-based biomarkers. So this is the new clinical staging of dementia. These are the people with these very specific genes. There's very few, couple 100,000 in the world. Asymptomatic biomarker evidence only. There was a lot of, so Ari and I in the back of the room were at AAIC, and we were sitting behind a famous psychologist who was practicing how she was going to get up and yell at Clifford Jack. Because for a while, Clifford and everybody said, okay, it's all defined. If you have the biological marker, you got the disease, forget it. Because we know amyloid is the key to this. If you have amyloid, you're potentially going to get the disease. If you don't have amyloid, you're not getting Alzheimer's. You've got something else. So it was a big controversy. But in order to respond to that in some ways, which is good to accept that behavior is important, they just added 1 million categories. But it still makes sense. So asymptomatic biomarker only means you don't have any cognitive impairments. But if you have amyloid in the brain, and worse if you have amyloid in tau, we're going to give you that diagnosis And what does that make a difference? If you have a diagnosis, you can treat. So that became the whole issue. Transitional decline. Remember I talked about mild cognitive impairment? Uh-oh, what am I doing wrong?
No, you're doing everything fine. I just have to make a quick announcement.
Oh.
Does anybody have a black Jeep with a bunch of coolers in the back of them? Is your truck, your back is up?
What's in the coolers?
I
Party time.
Who's the party? I know.
You guys thought it was just water in the back.
Good to go.
Okay, thanks. But you see what there's great understanding now too, that this whole mild cognitive impairment thing might be absolutely no problems. We know that some people with mild cognitive impairment who seem to have some cognitive decline from how they used to do, they're also beginning to show some problems in more complicated everyday life issues. So again, we're trying to recognize these behavioral symptoms. And then dementia occurs when there's mild functional impairment, clear evidence of a cognitive decline. The person may still be independent in their basic activities of daily living, but now they're having problems in daily life that need some assistance. And not until you get to stage 6 do you find total dependence on others. The whole point about this staging also is the FDA and all these other people require you to define what types of participants are going to be in your studies. So this is a way into that process. I also want to talk about Lilly's new drug, because that was a hot topic from everybody I bumped into. So this is Eli Lilly presented the phase 3 trial of Nanomab in early AD. And I'm going to spend a little more time talking with you about this, because they were kind enough to share slides with me, but also because it's a good example of how research gets done. In order to get your sort of study in there, you need a couple of phase 3 trials. These are big trials with Alzheimer's disease patients that generally cover countries, not just areas in the US, they cover countries. And you need those results to demonstrate. So until we had lecanemab or Leqembi, nobody had ever done that. Now we have another drug coming along that's doing exactly the same thing. And we'll talk a little bit about that. The things to remember here is, like all these amyloid buster drugs, it has antibodies that get rid of the amyloid from the brain. Again, like lecanemab and all the others, the issue is you have to treat things as early as possible. So that's why the whole issue is going to be, how early can you diagnose someone with Alzheimer's disease? How early in that rise of amyloid can you interfere? So it's a big issue. However, one of the things we'll talk a little bit about is that even if you start this treatment later in the course, it still seems to have an effect. One of the things that they did that was different than, and I got somebody in the back who can tell me if I'm right or wrong, but one of the things they did that was different from the first drug I mentioned, Leqembi, is they enrolled people by tau. So not just amyloid, but you had to have tau. Tau was evidence that there's clearly something going on. So the study said, let's target people who have both amyloid and tau, because we know they're definitely headed to Alzheimer's. Now, it makes comparing results between the two studies a little more complicated, but they also said, let's do 2 groups. Let's do a low, medium tau, and let's do a much more severe tau. So they have both amyloid and a lot of tau, so they're clearly more severe in this case. They had each study, each clinical trial has to have several things. It has to have a primary endpoint. So you have to tell the government, okay, I'm going to do this study, and I'm going to rest the results on, sorry, bang on your paper. I'm going to rest the results on this test, which is, as usual, more commonly now, a whole integration of a whole bunch of different paper and pencil tests and behavioral rating scales and things like that. But this is the thing that's going to measure our study. You have to do that ahead of time, because you can't run a study and later on say, well, these things didn't work, but look, this worked. You can't do things post hoc. after the fact. You have to decide ahead of time. I'm putting all my bucket in this one. But you're allowed these other things called gated or secondary outcomes. And there are several of these. The sum of boxes, which is what a physician rates the problem as. The Alzheimer's disease scales, ADAS-Cog, CDR, another rating system. And as well as we're also going to look at amyloid and PET markers. Okay, but the key is this one. So you live and die by this one. And this is what the results look like. This is that sort of combined cognitive measurement. And if you look over time from week 0 to 76, it starts to split off very quickly. But in answer to you, which was a very good question, it doesn't stop. You know, it doesn't go straight across here and it doesn't go straight up, but it most definitely slows the progress by quite a bit. You get a 35% slowing from baseline and a 22% if you look at everybody with tau, the more severe tau. So again, back to the fact that if you have very early disease, it has an even stronger effect, right? Because it's taking that amyloid out probably faster than that. This was pretty exciting findings. A lot of people, they made these slides available also because a lot of people like me had phones that we were pretending not to be. Oh, what's my email say then? Taking pictures at the same time. This is another example of a pre-specified. Did I miss a slide? Oh, this is the CDR. This is that sum of boxes. This is the thing the physician does when he or she starts asking you questions like, or starts and asking your significant other, everything okay at home? How's language going? How's this and that going? If you look at this rating, again, you see the same thing. In the low medium tau, the less impaired, you saw significant slowing, and you still see the same slowing here, and this slowing continues. The other interesting thing about this drug, I don't have that slide up because I didn't want to have too many slides, but the other interesting thing about this slide is it's eliminating amyloid from the brain. So as people get all their amyloid eliminated, they drop out of the study and just get falling. So it's a very interesting effect. I'll talk about that in a second. But if you look at, if you go to the government and say, we're going to do this study, we're going to put all our eggs in this basket, but we also can look at some other specific things. Like we're telling you ahead of time, we're going to look at patients diagnosed with mild cognitive impairment to see if it has an effect early in the disease. And we're going to exclude the Alzheimer's from that. And you see it has a very dramatic effect, a 60% slowing. Again, the earlier you catch this, the more effective it is. And the interesting thing about it is they invested all that much money in getting not only amyloid scans, but tau scans to show if we really know the disease is affecting somebody, then we know we're going to have an effect. This just shows you the interesting thing, both in their earlier study as well as this phase 3, the big final study that was done, the second study that was done. This is what happens to amyloid in the brain. It's much faster a drop even than behavior. So the amyloid is clearing very rapidly. And you can see this is the number of people with cleared amyloid. It's amazing. 80% reached amyloid clearance by 76 weeks on the drug. Now, that doesn't mean the disease stops because amyloid seems to have already done its damage, but you're really slowing the effect of this disease. ARIA still remains a significant problem. Maybe in some ways not as significant. It's a back and forth, but you'll see that there's still significant adverse events in a small percentage of people. But the bottom line is another pre-specified secondary analysis was to say, we're going to only look at those people with intermediate tau, the very early on people, and what is this drug? What's the effectiveness of this drug? 47% of part, by the way, from my notes, I had these numbers slightly wrong, so I was glad I got these slides, but 47%, because I can't write fast enough when I'm excited, but 47% of participants treated with the Nanomab showed no decline on the CDR. That's a pretty significant effect, number of people. 52% completed their course of treatment by 1 year, 72% by 18 months. This drug was really clearing amyloid from the brain. 40% less decline in activities of daily living, 39% slower risk of progressing to the next stage of the disease. And this is the one on this normal to MCI, MCI to AD, that sort of thing. So this was a really hot topic, an interesting topic. There's a couple of other new topics that started popping up. This one just barely kind of popping up because it's a little bit controversial, but clustered, regularly interspaced, short palindromic repeat system, CRISPR. What CRISPR is a very interesting thing that the Chinese got a lot of trouble in trying to, a few years back, a Chinese researcher sort of trying to adapt people. But what CRISPR does is basically gene editing. Can I go in and basically reduce the impact of ApoE4 genetically, change the genetics of the situation? Can I go in and find the wrong chef and get rid of the wrong chef? Can I develop drugs to do that through this type of system? It's a very complicated, very interesting system, but it's a little bit touchy because of the politics involved, because you're affecting genes. But there are some other approaches. Another gene therapy approach, which is sort of a one-time shot, LX1001 from Lexeo, really was an attempt to increase the ApoE. Can I go in and change your genetic makeup a little bit so that you get more ApoE2, the protective type of ApoE? This is very early. A few people studied, not a lot, but you know, it's also out there to build interest from people with money and things to do it, but it's really interesting stuff. This other drug was designed to interfere with tau production. It was a Biogen drug, and in a few of their first 80 patients, it appeared to be tolerated and appeared to be affecting tau. Because the biggest problem is, I can clear your brain of amyloid. I really can't do much about the tau yet. People still haven't figured out that process yet. The tau drugs that have been tried really have not been significantly effective. So they're trying all sorts of ways, because what's going to be the end of this is it's probably going to be a cocktail. I eliminate amyloid, but now I have to work on the tau that the amyloid already triggered in the brain. So there are a couple of other studies. This was a U of M study that came out just asking about, what do people know? You know, how many people are familiar with cognitive testing versus blood biomarkers? Very familiar, 30%, probably because 30% of those older individuals asked probably had cognitive testing, but only 2% knew about blood biomarkers. So that it really showed you ever been tested. Of course, very few people had ever been given blood biomarkers because they're brand new. But this sort of gives us an idea that some people have said, you know, when I first got to University of Michigan quite a long time ago, we wanted to do some screening in the geriatrics clinic. And the chair of geriatrics said, well, the last thing I want you to do is coming in asking patients about memory, because that'll get them all upset. We don't want any of that going on. Well, the truth is people do want to know how they're doing. And over the years, we've really learned that. So cognitive testing, neuropsychological testing are integral parts of geriatrics and neurology. But 86% of people said if my provider said I should go get cognitive testing, I'd do it. And I think it would help me. And maybe 60% said we ought to have this annually. So still you have this privacy concerns, and could it be inaccurate and things? So people have genuine concerns. But the issue was on the other follow-up testing, just nobody had heard of blood-based biomarkers, but when it was explained, they were perfectly willing to do it at the same level as would do cognitive testing. Yes.
Is there a difference between just having a brain scan and having a PET scan? Or is that the same thing?
Nope. I used to have those slides, but as everybody knows, I talk too much. But a PET scan gives you a picture of your brain. If I go to Voico here and I do a CAT scan of Voico or an MRI scan of Voico, I'm going to see what his brain looks like. If I do a PET scan, I'm going to see what his brain is thinking about. I get to see what's happening up there, what's ongoing. How is sugar being used? What aspects of the brain are most interesting? See? So it's a difference. The PET scan shows you activity, but the other thing a PET scan does, because it's positron emission tomography, it can show you what's happening in different aspects of the brain. So I can give it's a marker. So I can give you an amyloid drug that highlights amyloid in the brain, and that's how they do a PET scan. And I showed you those pretty pictures of where amyloid. You can't do that with an MRI. It just shows you a picture of a wall, not a picture of what's going on inside.
So it's more detailed.
Yeah. Well, it's more detailed and more involved. The first type of PET scan was positron emission tomography, was fluorodeoxyglucose, which I was doing studies in years ago. And so basically what we would have people do is look at a picture, give them an FDG scan, and we could tell what aspects of the brain were involved. The very first set of FDG scans done at University of California caused some stir because you give the scan, you wait 40 minutes, and then you see what's lit up in the brain. And there was a lot of light up in the frontal lobes and in the bottom of the brain. And we were, wow, this is really good. Well, the thing was, it overlooked the beach. And so people were looking at all these people in bathing suits. And so I'll just say that clearly some of the men must have had, excitement in the back of the brain looking at stuff. But it shows you what the brain is doing, whereas an MRI can only show you a picture. There was another interesting study that was done because a couple of years ago, right before COVID, well, right as COVID was beginning, there was a study that was presented by the European Union on the risk factors. What are the risk factors? Because if we could interfere with risk factors, we could do something. So everybody usually, age is the biggest risk factor, absolutely. And there are some things we can do about age, but they're kind of experimental. But everybody expected ApoE to be at the very top because that's that kind of genetic risk. It's about, if you carry the ApoE, is about a 7% risk, etc. What was on top was hearing aids. People who had hearing loss that weren't using hearing aids was 8%. It was the highest predictor of who would develop further cognitive decline. So hearing aids became really a hot topic, and fixing hearing. So why is that? Somebody with hearing problems, maybe they don't go out as much, maybe they get more depressed, maybe they withdraw more, they're not staying socialized and staying cognitively aware, coming to something like this and things. That's a hot issue. But it also appeared that other things were going. So this big study, the ACHIEVE study, looked at hearing and whether if I correct people's hearing, older individuals' hearing, do I reduce their cognitive decline? And actually, it didn't work. So the hot answer to this one in Amsterdam was it didn't work. But this was a number of different studies. In order to do this study, they went to people who had ongoing studies and said, can we check for hearing? Would it affect your study if we look? One of the studies they looked at was ERIC, which is a study of vascular problems in the brain. And many of those individuals, and overall, ERIC had more cognitive impairment than the other side, not dementia, but more evidence of cognitive difficulties. Those people had showed a pretty significant improvement. So there's something going on. But back to the issue of how do I prove this to the government? Their main proof didn't work for the whole population. But it highlighted that maybe we need to do some new research with a smaller population, a more specific population. Yes.
So you know, if people who are
We don't know that for sure. There have been a couple studies now. One of the we did a set of studies here that were begun that looked at individuals who get cochlear implants. What if you take somebody who had more trouble with hearing as they got older, and then you take that away with the cochlear implant? So it looks to us like that is the highest cognitive functioning group compared to those with hearing aids or those who didn't need it. But we don't know that yet. That's our initial findings, which tells us we ought to do a study in this area because we're looking at something potentially there. And the group with the worst cognition, people with hearing aids waiting for a cochlear implant. So there does seem to be something there. So much to my father's chagrin when he was alive was use your hearing aid. I had a reason for telling him to use his hearing aid all the time. Another interesting thing that came out of this one was the issue of opioids. Older adults who start, we obviously have these opioid problems starting, but older adults who start opioids after a dementia diagnosis face a very significant risk of death. I mean, this to me was really scary. If you look at fentanyl patches, 2/3 died within 180 days. Now, we agree this means there's something else going on and the person's got pain, got other issues, but it really raises the issue of, are these drugs possibly affecting things? So this becomes now another hot topic with the greatest risk of death being within the first 14 days. So what it says is if you have a dementia patient, you better watch that patient for 2 weeks and see what's going on because there may be an adverse event occurring. We don't know how or what. Yeah.
Question regarding also cholesterol drugs. I
Mhm.
read a while back that cholesterol causes memory problems.
Actually, I'll talk about that in a minute. I think I have, but good question. I'll give you your $20 afterwards. But the whole point of this is that what we understand, if you remember that picture I showed you before, those big circles, all of these other disorders we get as we get older contribute to the risk of Alzheimer's. So we know that high cholesterol, the metabolic syndrome, we know that people who have the metabolic syndrome, obese, hypercholesterol, hypercortisolemia, all who have that cluster of things have a higher risk for Alzheimer's. It's tied in. The group in front here is real interesting. So it does seem to be a factor that these other comorbid illnesses we have seem to be risk factors, seem to add to the risk of developing Alzheimer's disease. We don't know how. Some people say, well, the blood-brain barrier starts to get fuzzy, cholesterol gets it, who knows what happens. The clear idea is not there yet, but there's a lot of work being done with that. But we know that it means if somebody has conditions that aren't taken care of, they ought to take care of them. Like I had really high blood pressure, and my old pal who was my doctor for like 40 years used to say, oh, it's sort of like the memory thing. Oh, don't worry about it. Everybody gets high blood pressure. And I'm going, yeah, but my blood pressure is getting high enough that I'm noticing, and so I went to a cardiologist who went, oh my God, look at your blood pressure, and then I have super low, nice 120, but it's a difference in belief. But we know that those high blood pressure, all those kind of linkages in that metabolic syndrome all leads to a higher risk. Now, some people yes, some people no, but we know it adds to a higher risk. There are many people who carry the ApoE4 genes. They don't do Alzheimer's, but it contributes to the risk. So since we don't have the world's best meds yet for this disorder, and even if we did, we should be trying to reduce the risk. Tell people to eat properly, to exercise, to do all those things. I'm not talking about that in this study, but there are all sorts of things we can do to take our own work on this. That you don't have a drug, but the heck, I'm going to work on what I should do. Take care of myself and go to see my physician.
Does autoimmune diseases is that in that cluster of increased chance of developing?
It's not, I don't think that's really clear yet, honestly, but people have gotten really interested in it. because there should be something about those things that there's another disease called Cushing's, for example, that leads to high cortisol levels. For cortisol, we know the brain uses cortisol all the time for memory, but high cortisol actually kills memory cells. So why don't people with Cushing's have a higher risk of Alzheimer's? Well, nobody's done that yet. You know, nobody's really looked at that. We know that individuals with HIV have a higher risk of cardiovascular disease, a higher risk of diabetes, which may link to a higher risk of Alzheimer's disease, but nobody's really been looking at that till the last couple of years. We have a study in Africa looking at that because, you know, there we have a very large HIV population, and we're wondering, you know, is there a relationship here because of all these comorbid factors? Now, another thing, I put a slide sort of related to this every year so that when a friend of mine sees my slides, she'll know I'm talking about gut issues. It irritates the hell out of me that gut people are right. But we know now, after a lot of research, that the brain does a lot for the gut, and now we know the gut does a lot for the brain. So there were a couple of studies just noticing people with chronic constipation, they have a much worse risk of cognitive problems. And also there was another study that's just showing the beginnings of the ability to say, these things in the gut seem to reduce risk, these seem to be increased. So that idea of the stomach running the, you know, my stomach rules me because if I go out here in Detroit, I'm going to eat from every little tiny restaurant that looks cool. But that's running my brain, but in a different way. Because I like to eat, but you know. So the gut, I put the gut in here as my homage to those gut people that it turns out they were right. Because for years, gut people were saying, you should be studying the gut because the gut affects the brain, and all of us kind of laughed at them. But they were right. Another study that was out there, I should be finished in a little bit. Another study that was out there looked at the first ever, this was the first, you'd think we've done this before. This was the first study in every single county in the US looking at the prevalence of Alzheimer's disease. First of all, I don't know why, but 3,124 counties doesn't seem like a lot for the US, but it turns out that's what we got. Eastern and South and the Southeastern US really had the highest prevalence of Alzheimer's disease. Part of that may have been affected by the highest prevalence in terms of African American and Hispanic groups that have a higher prevalence of effects of stress, of poorer health care, of higher comorbid illnesses are higher in those counties. But what the call of this study is, you know what? We know where Alzheimer's disease is the worst. We ought to darn look at it. You know, another thing that was interesting was, you know, you kind of look at this, Michigan, we're not bad for development of Alzheimer's. If I look at Vermont, it's as bad as some of the counties in the South. Now, my wife comes from Vermont. What the heck is in Vermont? It's beautiful, but it has a high risk. So it's not understood why. So there's lots of epidemiologists really interested. Another study that had already been done once, but nobody paid attention to it, the Baltimore Aging study. In some ways, I don't feel like they paid enough attention, but there's a new study that came out about volunteering, and really that if you volunteer later in life, it's really good at reducing your cognitive change. The Baltimore Aging study showed us if you volunteer in an elementary school, in the school systems, older individuals who volunteered as sort of the grandmother, grandfather in the school, those folks had better looking brains than people who didn't. So this was another study demonstrating that you can't stop even as you get older. Globalization, I'll mention briefly, a lot of interest. Suddenly I was popular because of work I did in Africa. A lot of interest in Africa, but also a lot of concern about, we want to see all these individuals and all this genetic information and things, but we have to have a little bit of a balance there, because what are we doing with all this genetic information? So a lot of super companies. There are a lot of take-home messages, but the main take-home message, I was talking to a friend who said, you know, other than the Nanomab and things, there wasn't a lot of super excitement. I mean, one of the most exciting things was constipation at AAIC. But that's an everyday thing, which is important to say those things are being looked at. But the real fact that was going on, I think, at this AAIC conference was we've had so many exciting leaps and bounds. Nobody has said we need, a lot of researchers were basically saying, hey, we need to stop and start refining the research we're doing. So there was a lot of interest in that, a lot of interest in being inclusive in science, in looking globally at studies that are done and things like that. So it was kind of fun. Let me talk to you briefly about the Alzheimer's Center, because I'm doing okay, Stephanie. See, it's amazing. Stephanie doesn't need to raise any signs in the back or do anything. So the Alzheimer's Association, we were really basically the first one. We are a combination of 3 universities. We're one of the National Institute of Aging. There were 32 of them, I think, when we started. Now they're 36. 37. Somebody's always sneaking in there at the end. But these are centers of excellence designated by NIH to do research in Alzheimer's. Now, we also have a Macquarie at U of M that's designed to do education about Alzheimer's and aging, but we are supposed to do human-based clinical research and those other activities that tell us about laboratory research that tells us about Alzheimer's. And we are Wayne State University right here, U of M, and MSU gets to have 2 places, but you know, Grand Rapids and Lansing, we'll give them those 2. But this is really a research belt across the county. It's very interesting. And everybody shares in this. We've got an incredibly complicated array of people, but we have an administrative core. We have a clinical core that does all of our clinical evaluations. Every year, people come in, some 630 people come in every year for an evaluation from us. And I'm trying to push Ari to 800, but he's a little resistant to that. But our neuropathology core that studies brain changes, data core that looks at all this data from all this stuff and tries to funnel it together. I'm constantly bothering the data core for data. We now have a whole pile of people in here working with Kelly. It's fantastic because we used to only have one person, which was the old, you get hit by the bus, the whole center goes down. So that's changed dramatically because data is the answer to all this. Because we have to look at all of this data and look at it combining different aspects. We have a biomarker core that's looking at different biomarkers involved, these blood-based biomarkers. How can we look at new ones to look at this more effectively? An imaging core looking at PET scans and amyloid scans, outreach and recruitment score, finding people for all this. And at the center of this in many ways is our Peter Lichtenberg here, Irving Vega, Roger Albin at U of M, Irving at MSU, but this is our education component. Because remember what I showed you before? We don't have nearly enough geriatricians and neurologists for what's coming down the pipe on the number of older people. There's a lot. We have the UMAP, which is that yearly process. Notice this guy here. Do you notice this guy? He used to have black hair, and it all seems to have disappeared. But these are individuals 55 years and older. We're interested in people volunteering with or without memory problems. And we do this free evaluation. We try and reimburse people for their time and things, but it looks at blood-based biomarkers, structural imaging, a lot of different aspects. The key to all this is tying these studies together. That's what these co-enrolled studies are. So we have several studies ongoing, and we used to have none, but this has popped up over the last 10 or 12 years or so, is looking at multiple different studies that all enroll in our Alzheimer's Center. So Ari in the back gets panicked when I go, yeah, but maybe we'll have 800 people a year instead of 600. I go, wait, we can't. That it's going to happen because we're getting more and more people co-enrolled and they're being followed in studies. So they go through the same process we do, but the study does.
In your previous reading, you stated that there are certain diseases that have higher incidence of connected with dementia. Could you briefly mention what those diseases are that have higher incidence?
Hypertension, cholesterol, the metabolic syndrome, obesity, all of those things seem to link to a somewhat higher risk. You know, I used to have a slide about what to eat, and I used to have my Popeye fried chicken sandwich, and then I was told to get rid of that because potentially it was clearly a Popeye sandwich. I don't like the fact that this is all being recorded. But all this set of studies co-enrolls in the Alzheimer's Center, meaning we can have even bigger sample than 600 running at the same time. So it's really cool and neat, but it's incredibly complicated. This is one of the studies going on. TDCS, Brain Hampstead, is looking at studies that look at mild, sort of like the 9-volt battery type of current, that if that is sort of running through different areas in the brain at the same time, it appears to improve learning. And the latest thing is I give you an MRI scan. While I'm doing that, I decide what area needs the most, the fMRI, what needs the most activity, and I send you home with this. And you can go do it at home. There's lots of this interest going on. Why is it? Because we know that these amyloid drugs are going to clearly slow the process, but you need to be doing more. We understand that too. We have the Electra study, Boyko sitting up front there, snickering at me when he says things he thinks I might be saying wrong, but I'm not gonna. But this study is a study of EEG. It's an early detection study. So I thought, since I have a few minutes, I will tell you a little bit more specifically about this study, because this is a good example, also because Sophie made some really cool slides for it. But this study sort of shows you what everybody goes through in one of our research studies. And this study has already spent we have several more ongoing now, interesting studies looking at EEG and cognitive testing, a lot of other interesting things. Several papers have already been done. But every study to get funded by the government has to address a problem. In this case, health disparity. Why do Black Americans, why are they more likely to have dementia, and why are they less likely to get it treated? What can we do with early identification? How can we better understand potential signs in the African American community of cognitive problems and find a better way to do that? Every study has inclusion criteria and exclusion criteria. And that kind of irritates people sometimes. Well, why can't I be in your study? You know, I have a history of stroke. I want to still be in your study. For the government, we have to have very clean, specific types of groups so we can better interpret our results. But as you move to more and more complex studies, then you allow. So, for example, phase 1 studies in the government, what they call phase 1 clinical trials, are usually healthy controls or just a few patients with Alzheimer's. By the time you get to phase 3 studies, it's a very wide net for people. But every study has inclusion and exclusion criteria. This one says you have to be 65 and older, because if you're 25, it's interesting, but your risk of cognitive change is not exactly so high. But concerns about memory in some ways, like when I think about it, I don't think my memory is as good as last year. My kids started saying this when I was about 27. Right? You live independently and you can complete the EEG, and the exclusion criteria is psychiatric illness, alcohol or drug abuse, major medical illness, because we have to be able to interpret the signs in these initial studies of what the results mean without a lot of confusion. Participation. So this is the steps that you go through in this study. People have to understand this. It's important to volunteer because it helps us tremendously to find things, but you're also volunteering some of your time. But if you remember, there was that study before that said if you volunteer, your brain gets a little better. So that's part of that process. So you go through a preliminary screening over the phone. You get informed, you do an informed consent. Every study by the government says you have to sign an informed consent that tells you all about the study and all about any risks and all about time of day and all about your whatever. It's like a 15-page document. So it takes me more time to go through consent than it does my cognitive testing. But the reason for that is you're trying to tell people if you don't like doing this study, you can withdraw at any time, any of those things. Then there's an hour visit for some cognitive testing and doing the EEG. That all gets done. Then there's another visit for some more testing and a clinical exam. this is all part of entry into the into our UMAP, into the overall Alzheimer's Center. But this study is separate. It's a separate NIH funded study, but it cooperates with the overall Alzheimer's Center. And then the consensus conference is critical because all of those studies I showed you before, they all go through the same consensus conference pretty much that occurs at the University of Michigan with people from all over and involved in the other studies. But it's the study where you get a bunch of people in the room that say, yes, this is mild cognitive impairment, or no, this looks like normal, or yes, this looks like Alzheimer's. Because so far, the gold standard is a group of people who understand sitting together in a room and making a decision. It's about 96% accurate in terms of diagnosis, but who's got the time to pay all these people to do it? We do. But it's true. And then you go into a longitudinal study every 6 months and every year part of the study. Now, when you read that consent form before you do any study, I recommend you must look at what are some of the risks and what are some of the benefits. So this is an EEG study. You may get gel in your hair. You may want to do this on Friday before you have a hair appointment or something like that. You might get bored or frustrated by Bruno or Sophie or Lorraine or anybody asking you questions about your memory, or you're sitting there with an EEG. It's not really typical at all, but it could happen. And there's always a confidentiality risk, and we'll talk about that in a minute. But you get feedback about any diagnosis. You get lots of other info about community resources and the other centers, and you get the opportunity to be part of UMAP, part of the whole overall system through these 3 universities that targets everybody and helps them, and also gives them the most information about the newest studies. I know I'm kind of losing my time, Stephanie, but I'll be done in a second. But I do want to mention that in your consent form, you always look at what it says about confidentiality. Do they have an NIH certificate of confidentiality? Have they been approved to, in the ways that they hide that information, that they keep it from the medical chart or whatever? That always has to be in there. There are barriers. I mentioned hairstyle. It's time commitment. Look, we're asking people to come in for 3 hours or 4 hours. Some people, we don't offer transportation, but UMAP does give you transportation for that part of the study. So it's different aspects. Volunteer means getting involved and giving up some things, but it means helping a lot of people in the process. How does this work? The only way it works is through joining a whole bunch of people together, the village thing, you know? Yeah, this is work on. I knew we couldn't resist.
Can you address the need for study partners?
Yeah, so this study is important. Work has a good point. The one thing that characterizes all of these studies, they're a part of the University of Michigan Memory and Aging project. Part of our whole Alzheimer's Center is you do need to have a study partner. Now, Electra, this study will take you without a study partner, but then you can't be part of UMAP. We're working on that with the government. But so far, the government says you need to have a study partner because we want somebody else to give a second opinion about how you're doing. Like my family would say, that guy's long gone, and I might say there's nothing wrong with me, but we need that in there.
Bruno?
Yeah.
Just want to clarify that
Yeah.
the study partner responsibility is not the same as
Right.
participant.
Study partner is part of the UMAP work that helps us with diagnosis. You do get asked questions about some historical information, questions like that. Yeah, you don't go through, thank you, Sophie, because you don't do the EEG, you don't do the testing, but we need that second opinion because we know that historically, we can't always rely upon a person to tell us the best about how they're doing. And if we can do testing and get somebody else's opinion and talk to the person involved, we get a much better picture about what's going on. Did I get that right, guys? Okay, good. Thank you. So Sophie's caught me twice already. So. We have the driving study that we're doing that also looks at older drivers along a number of ways. We have drivers who drive through a simulator. This is a little computerized program. We have a much bigger one, but we noticed two problems with this. One is people tend to get a little sicker because when you make a turn in a simulator, your body goes, hey, I'm going this way, but the simulator is just a picture. It doesn't go away. So your stomach is going that way and so usually that's fine. People might feel a little bit of discomfort initially, but then they get used to it. But it uses a simulator. Then we have people drive on a fixed course and then driving for over a month with a little setup in the car. So we kind of know where you are, but that's all protected by confidentiality. But we know what all the cars are like around you. We know the driving and other issues, because think about it. What was the earliest signs of having cognitive problems? Having problems with complex things. I used to do a lot of research in walking. Like what happens when I'm walking down the street and there's a crack on the street? How do I step over that crack appropriately? I know that one of the problems is as we get older, we fixate on that crack because people like me have a bum knee and know I can't get over that. I also have a rebuilt back, but that's beside the point. But I can't get over that crack, so I'm going to stare at that crack, and at the same time, I'm going to step right into Woodward Avenue and get hit by a car because I'm so concentrating on that. Whereas a younger person just looks and up and registers that. So we're trying to understand all those things. But if you think about that, about walking, what's infinitely more complex than walking is driving a car. So we want to look at some of the earlier issues that may occur when people drive cars. It's a complicated process. It's just hard to drive a car. A couple of other quick studies. Diversity CID that's going on here, I'll talk about in a sec. Super aging. The STIM study is the one that we mentioned with Ben's doing. The All FTD study is a study that looks at problems with the front of the brain, not classic Alzheimer's, frontal temporal image. This is Diversity CID that, like Electra, is recruiting lots of people in the Detroit area. The whole idea behind this is develop tools to diagnose and treat cerebrovascular disease before it causes cognitive problems. So diverse BCID is sort of one of the hot topic studies going on now. Another one that's just started is super aging, where they're really interested in people who are 80 and over who have no problems. I mean, we're spending all this time looking at people who have problems. Why don't we spend time looking at people who are 80 who don't have any problems? You know, what about the fact that, remember that PET scan I showed you with amyloid? 20% of the population of older individuals are walking around with a brain full of amyloid that looks just like an Alzheimer's patient, but they got no problems at all. How come? What's protected? What's going on? So this study is really interested about what are those protective features. Let's not worry so much constantly about risk. Let's worry about protective features. We also do more than research. There's Edna. We have a wellness initiative that looks at stress and resilience among caregivers. Very interested in helping caregivers across our different sites. I always have a picture of Laura here because then I begin to, my breath begins to release. I feel a little better. There's Laura, our wellness person. She does meditation. Somehow I can't do it. But anyway, we have the Lewy Body Initiative for that disorder. We're one of the really groups and centers among the Alzheimer's centers across the country interested in this very small and interesting disease sort of involved with Parkinson's and a lot of other things. We have our brain bank that takes after people pass away, they can, if they've been in our studies, they can donate their brain, part of their brain for additional studies and things. And that's it. And I'm only, Bruno's 8 minutes over, so that wasn't bad, right? Stephanie is sitting in the back screaming and yelling in the past. So that's why I thought that intervention was actually bad. So. Any questions? Yes.
Can you address depression bringing on Alzheimer's, also bringing on Alzheimer's?
So those are two very interesting pieces. What is the linkage between depression, which we know affects cortisol and other things in the brain? And the answer is, I don't know for sure. One of the reasons is because back when I was first doing this research at Mount Sinai in New York. Anybody who had depression, we didn't want to see. Sorry, your brain might be different. We wouldn't want to see. So for years, nobody studied depression. Now there's a lot of interest in that, both late life depression that occurs, as well as people with a history. But trying to get the picture on that, it seems to be a risk factor, but the picture is not perfect. You know, a fall is an interesting problem too, right? You fall and hit your head. We know that there is some data that suggests people with significant head injuries, usually those that break the blood-brain barrier, have a higher risk of Alzheimer's. But an actual fall, it's not clear. I mean, but we do know things like if you get your hip replaced, that often leads to kind of a downward force. My mom got her hip replaced when she was first developing Alzheimer's, so she never remembered. So, you know, she broke her hip twice because she didn't remember she had a fall. But her doctor said, it's great. Look how well she's doing. She doesn't even need a walker. Well, she didn't remember her fall. Okay. Those kind of issues. Anything else? Yeah.
Trauma,
That fits within the depression category, looking at emotional trauma.
like, adverse trauma.
That's another real interesting piece because for a long time, I'll just give you an example. But for a long time, we said that individuals who are African Americans have a much higher risk because they have greater obesity, they have greater cardiovascular disorders, they have this and that, like it's their fault or anything. And what's been demonstrated now is, whereas those factors have some degree, the really biggest pusher is the amount of stress that individual went through. And the amount, so that we understand actually that where you live, lack of green space, lack of all those things adds to stress and actually contributes to the problem. There's more and more research going on now with early stress effects and things like that. But again, it's, you know, there wasn't that money to do that research. So now there's much more interest. Yes.
Can you say a little more about the blood biomarker test and what exactly it's testing for and how, so you were saying 80% accurate, do you think that's gonna get better?
I mean, that's in the first study
Okay,
that was done. And that's a study, see, that's the interesting thing. That's what's great about all this research. I say, well, I took 30 people with Alzheimer's disease and 30 normals, and look, I can perfectly differentiate them. But when you go out into a big community in Denmark, you know, in Holland and test everybody, it's a whole different aspect, because what about those other things that may contribute and may look like Alzheimer's? So actually 80% accuracy was pretty cool. All it means is you have to look close. So these blood markers, they've, you know, it's only the past couple of years. I can remember sitting at, I think I was sitting next to Ari or sitting next to Ben Hampstead or somebody at an AAIC probably 8 years ago or whatever, and they were talking about something called NFL, neurofilament light. And like, this was it, boy. If we study NFL, we'll know all about amyloid in the brain, blah, blah, blah. Now, didn't pan out. It tells us a lot about certain aspects of the disease, but certainly isn't like tau markers or beta markers, because the thing is, it's hard to get stuff out of the brain. You got a barrier in there, so it's hard to tell that these blood-brain barriers work. But you know, another big interest is eye disease and things that scanners that look at the eye, because the eye really is a window to the brain, and you can find amyloid in the eye. So it's all interesting stuff. That's why we do the EEG research. We're trying to find early markers that would be easier to do for people, so that you could check a wider range of people who don't want to go in. But 3 years ago, or no, I keep forgetting about COVID. So maybe 6 years ago or whatever, when they started one of the new diagnostic criteria for Alzheimer's disease that included PET scan abnormalities, so amyloid and tau. And the head of science for a major Alzheimer's group in the world stood up and said, by golly, we're going to have PET scanners all around the world to do this. And I'm sitting here thinking, no, you're not. But blood-based biomarkers give you that chance. And even if it doesn't give you the total picture, it gives you an idea. But we don't know what HIV does to that for sure. We don't know what cardiovascular disorder. That's why that first study was so important. We're collecting blood on, it'll be a total of about 1,200 individuals with different disorders and also healthy controls in Africa, because we also don't know whether different cultures, different areas has the same effect. Yes.
I'm a little confused.
So am I.
About hearing, because I
Yep.
hearing aid, but. And I get a lot of literature from my hearing company about, the dementia is connected to hearing.
Yeah.
And now you're saying it doesn't, and I felt that hearing was the reason hearing loss was a factor, was social interaction. When people could not hear, they're not participating. But then where I got confused was then you later said, well, people who volunteered have less incidence of dementia, and that's where you're participating. So what effect does social interaction have with dementia?
It's a complicated picture, but we know that if people stay socially active, it reduces their risk. The hearing thing was kind of a surprise, but the hearing thing may be that if you're a healthy individual with no chance of Alzheimer's disease, affecting your hearing is going to make you feel better, but it's not exactly going to affect something. It's more of a picture that there may be something else going on. But the social factor is like use it or lose it. It really makes a difference. Staying socially connected, coming to something like this, playing bridge with your friends, learning how to tango and stuff, and learning how to move your feet, remembering positions. Any of those things that are social reduce the risk of Alzheimer's. They did one study, for example, we have a drug called, one of the very first drugs called Aricept. Didn't affect amyloid, didn't do anything, just increased the choline, the neurochemicals in the brain that help the brain remember and do things. But eventually, of course, cells die, but for that process to only work. Well, they found that a study of exercise and social engaged exercise had the same effect as taking the drug. So, it's a powerful effect. We know it's a powerful effect. Staying active is a powerful thing. So that's why everybody thought with the hearing thing at first, it means you stay home, you don't do as much, you don't do these. But it may have a more complicated picture. Because we don't know. Yeah.
Is there a relationship between cancer survivors and dementia? And I thought about that because when you mentioned the use of blood markers.
Yeah.
So is there, like, for example, a relationship with Alzheimer's or specific kinds of cancer that seem to indicate a relationship?
We don't know yet. There's a lot more interest. Why is there interest? I'll tell you why there's a lot of interest in this. Is because cancer is treated very differently than Alzheimer's. And only in the past, really, I feel like, I know people have been doing research, et cetera, and so forth. But really publicly, it was only the last Alzheimer's Association meeting and this one that began talking about having cancer doctors, researchers coming to Alzheimer's meetings to give talks about this is how we cure cancer. They don't just say cancer, we give a pill. Like we're going to give everybody with cancer liquidity, or what can be, right? I don't know. But anyway, we don't just give everybody that pill. In cancer research, we focus the type of medicine to the type of disorder. And last year there was a study published that really suggested we can do this. Even the genetic stuff that's going on now, or looking at how to affect, that all comes from cancer. But the effect of long-term cancer is nobody's really studied because a lot of these studies haven't been done. Framingham, which is a large study, and the California aging studies that are going on, those are taking all comers and will know better. Okay, thanks, folks. Don't forget in the back.
Thank you very much.
All right, please stick around. We have some lunch in the back. Remember, if you haven't already, get your validation pass for parking. Next speaker series is September 20th. Same time, same place. So if you're interested, you can email me, call me, and get on the registration list. And yeah, thank you so much for coming out today.
Is that Amanda?
That is Amanda. Yep, Amanda
That's
Marr.
a super agent study. Gotta look at
Yeah, it's gonna be a really good talk.
better than this one.